Now, last week we did the binomial nomenclature. So, can you remember the rules of binomial nomenclature? What are the rules? Why we use a binomial nomenclature for living organisms? What is the reason? The reason is when we are using a common name in scientific studies, that make problems because the same organism is identified in different names in different countries and different areas of the same country. So it makes problems. So when we are doing a scientific study, so all the countries need to understand about the organism using that particular name. So using a common name in everywhere in the world, so every country in the world is very useful and helpful for the scientific study. That is why we are using a common, the scientific name for each and every organism on this planet Earth. So all the organisms, they have specific scientific name. Who introduced this scientific name? Will the scientists introduce this scientific or binomial nomenclature? Yes, Carolus Linnaeus. So Carl Linnaeus. So that is the science. And tell me another tell me another contribution of Carl Linnaeus or Carolus Linnaeus for science. Another contribution of him for science. This Carolus Linnaeus. Can you remember? This Carolus Linnaeus, yes, he introduced the binomial nomenclature. That is correct. And I am asking, tell me another contribution of that scientist for this classification. Huh? Can't remember. Yes, he is the scientist introduced that taxonomic classification system. The taxas. What are the taxas? Domain, kingdom, phylum, class, order, family, genus, species. That is the taxonomic level. Those taxonomic levels also introduced by Carolus Linnaeus. And this binomial nomenclature, so giving a scientific name for each organism, is also introduced by Carolus Linnaeus. Right. So according to that binomial nomenclature, we have learned some rules. And when we are writing or when we are reading a scientific name, so we have to follow some rules. For example, there is an organism called tiger. Common name is tiger. But in Sri Lanka, we name it as Kotia. Kotia name, tiger name. Another country, China, the Japan, so it makes some problems for scientific studies. So when we are doing some research on the tigers, so then we have to use a scientific name. So that scientific name is valid for anywhere of this world. What is the scientific name? Panthera tigris. Panthera tigris. So then, what are the rules used to give this name? One thing is, the scientific name should have two names. What is the first name? Genus name. What is the genus name of this particular organism? Panthera. And second name is species name. What is the species name? Tigris. So then remember, first rule of the binomial nomenclature is giving two names for the organism. First name is the genus name. Second name is the species name. Right. That is the first rule and second rule. And the next rule is when we are writing this particular name, the first letter of the genus name should be a English capital letter. And all the other letters, including the species name, should be simple letters. So we are not, we do not have permission to violate these rules. So if we make mistakes in scientific nomenclature, Totally we do not get marks. First letter should be English capital letter, all the other letters simple letters. There is another rule. And what is the other rule? When we are writing this particular name using our handwriting. Okay. So yes. So I'm going to write this name here. The name is Anthera Tigris. I wrote this name in my handwriting. These are my handwriting letters. And what is the rule? I have to underline each name separately. It's not a single line. Genus name should underline and species name also should underline. If you are not underlining that, it is not a scientific name. But it may be a scientific name, but you are not following the perfect rules there. You are not having marks. Right. But when we are when we are typing that name in an electronic screen or in a sheet paper, we have to use italics. So we have to use italics. That letters. Here. And do we need to underline it? No, we do not need to underline. We are not underlining. If underlining this, the written, the type one is wrong. So those are the rules we have to follow using this binomial nomenclature. Understood? So I think we have we wrote the necessary information related to that binomial nomenclature. Right. Today we are starting a new part of this classification, that is using a key to identify the organisms. Use the key. We are going to use a key to identify the living organisms. Key. Okay. So this key is named as a dichotomous key. Dichotomous key. Dichotomous key means we are always using, and for example, now I am writing a list of these much here. Here table, pen, whatever, desk. Yes. Okay. Eraser. Another one. That's enough, right? Right. Now I am asking you to not scientific name. I am asking you to classify these the given materials using a dichotomous key. Yes. Now, how we dichotomous means each time you are using two statements to classify the things. Have legs and does not have legs. No, I can first categorize them as furniture and stationery. That's better, eh? Furniture and stationaries. Now, what are the furnitures here? Chair and table. Then here pen, book, book, ruler and eraser are stationaries. Again, I use two statements to classify these furnitures. Furnitures. What can I use? Yes, can sit On nil. Yes, can sit. Used to sit on cannot. Then it is chair and table and desk. Table and desk, right? So like that, we can use always two statements to categorize the things given in the list, and finally we are identifying the particular material or the instrument we are given. Now we identify the chair. Chair is the particular thing we use to sit, and it is a furniture. So using this two-time statement procedure, finally we are going to identify the living organism. So like that, now we are going to do a little exercise before introducing that one. So I am writing a list of animals here. Animals again. Butterfly, rabbit, fish, elephant. Elephant. Rabbit, fish, a snake. And crab. Crab. And what else? Bird. Can I come? Parrot. Now enough. Enough now, right? Right. Now tell me two statements to classify these organisms. But you have to use only outside characteristics. No, you have to use the body features, outside body features only to classify. First one, you legs. First one, legs, absent. Right. Who are the organisms with legs? Butterfly. Frog. Legs absent. Fish and snake. Okay. Now I am going to classify this list now. Make a list classify. That means butterfly, rabbit, frog, crab, and parrot. So what are the two? Wings. Yes, wings. Present. Wings present. Wings. Absent. Wings present. Whose other organisms? Butterfly and parrot. Wings absent. Rabbit. Frog. And parrot. Right. So then I am going to differentiate this butterfly and parrot. I have a beak. Yes. Beak present. Beak absent. Beak present in parrot, absent in butterfly. Okay. Then I am going to classify these things. Bracket, bracket, yeah. Absent. Who have the rabbit? And absent? Bracket, crab. Then pets. That this is bigger one. Yes, the wet then have wet skin and no skin. So, but are we classifying all the organisms yet? No. Whether they make it or not. Fish and snake. Huh? Fish and fins, snake. No. Here, using these two times the statements, finally we separate all the organisms individually. Understood? We separate all the organisms individually. For example, snake is the organism without feet and without legs. Here. And when we take the crab is the organism without skin and without fur and what else? Without wings and with legs. The organism with legs and without wings and without skin, without fur is the crab. So using different characteristic features, finally we identified the organisms individually. Alright. That is the function. That is the reason for using this dichotomous scheme. But remember, in classification, we are highly using this dichotomous keys. Okay. The method of using the dichotomous key is somewhat different from what I did here. But remember, always we have used two times statements to specify the organism at once. For example, at first time I select legs present, legs absent. Okay, if one statement I select as is present something, other one should be the opposite of that one. Legs present none, other one should be present, weak present. No, other one should be legs absent. If I say presence of weak, the other statement should be absent, weak absent. So if I select a particular statement to separate or classify the organism, other statement should be opposite of that one. So using these type of criteria for the statements, finally I am going to select the living organism or the final organism there. So then I will show how we do it using a scientific way. Now legs present. Who are the organisms legs present? Butterfly, rabbit, frog, crab, and parrot. There are many organisms. And who are the organisms legs absent? Fish and snake. Yes. Now, when we are classifying the organisms, so legs present, I have 1, 2, 3, 4, 5 organisms with legs. 2 organisms without legs. So in the first statement, I wrote legs present. So then I have 5 organisms. So therefore, I am going to classify those 5 organisms in my second statement. Therefore, I ask the person who is referring this one, legs present is classified under number 2. Right? Legs present organisms are classified under number 2. First, I will classify one set of organisms. Legs present is classified under number 2. So what is the list? Butterfly, rabbit, frog, crab, and parrot. So what is the next one I can use to classify them? Wings. Wings present. Wings absent. Wings present, how many of them? Wings present in butterfly and parrot. How many of them? 2 organisms still I have. So then I am going to wings present, the organism I have 2. So these 2 organisms will classify under statement 3. Therefore, I have to say that wings present organisms are classifying under number 3. Who are the organisms? Butterfly and parrot. Then beak present, beak absent. Then what is beak present is parrot. Beak absent is butterfly. But beaks absent I know realistic. Rabbit, frog, and crab. What is the number I am going to classify them? 4. Number 4. Number 4 is the I am going to classify them. Right. In a number 4, I will write it as 4 per percent per absent. But per absent, there are 2 organisms again I have. 2 organisms per absent. What is the number I am going to classify them? 5. This is number 5. Wet skin, no wet skin. Then I can write direct name because I have only 2 organisms. Wet skin present in frog, wet skin absent in the crab. Right, now that list is classified. But here the measurement of sector will separate the other. So then what should be the number I am going to classify then? Number 6. Therefore, I will say they are classified as number 6. Have fins, no fins, fish and snake. See how to read this. I have a list of organisms. Now I am going to classify them using 2 time statements. First statement, legs present organisms are classified under number 2. Now they get wings present, then legs present type wings it is classified under number 3. And the beak present. Then parrot is the organism with the beak, with wings and with legs. And my legs absent legs absent is classified under number 6. Here. Legs absent here is classified by fins without fins. Fish and snake were classified. So they have the legs present. And wings absent. The wings absent organisms, how they classify? They are classified under number 4. Per present, per absent. Per absent here classified under number 5. Wet skin, no wet skin. Remember, this is the method of using a dichotomous tree to classify the organism. But remember, in the exams, you are not given this type of very big list of organisms. You will be given only 3 or 4 organisms to classify by using this particular classification system. Understood? Right. In your handout, do you have the handout with you? Take out your handout, the classification number 1. And then the last page, final page. In the last page, you are given a list of organisms. What are those? Silverfish. Who's silverfish? In the ocean? Yes, it's an invertebrate fish. Yeah, it's live in lakes, streams, rivers, inside the books. The little insect who are eating the books. Silverfish. Then see the importance of using a scientific name. The common name is silverfish. Then someone may think it as a fish swimming in water, but it's not actually fish. Silverfish is a common name, but the scientific name is a different one. Like silverfish, butterfly, and housefly. Housefly, what is the other one? Beetle. Then here, so what is the first 2 descriptions to use separate these two? Possesses wings, do not possess wings. They can first that means we have to look at very carefully. When you are given the list of organisms, first you have to see who are the organisms given there. And you have to select by your own what is the 2 statements I have to use to separate them. You have to select. The may select wings present, wings absent. Wings present, wings absent. Wings present. Wings present, how many? 1, 2, 3 organisms are there. Wings absent? Only 1. We can write the name directly because we have only 1 organism. Yes, answer. Then what is the organism without wings? Silverfish. Silverfish. Then the organism with wings, there are many. The list of organisms, therefore we have to take them into number 2. Number 2. Who are the organisms? If I classify the silverfish, if I separate the organism, then I will remove that from the list. I put a mark. It was selected. And wings absent, wings present, butterfly, housefly, beetle. What is the 2 times statement I use? 2 pair of wings, no 2 pair of wings. Right. 2 pair of wings, no 2 pair of wings. A pair of wings, who has a pair of wings? Butterfly is a and beetle is a right. Do not have 2 pair of wings. Housefly. 2 pair of wings can how many wings? 4 wings. Butterfly has only 2 wings. Butterfly has 2 wings. The fly. Housefly has only 2 wings. Butterfly means. It has 4 pair of peaks there. Right. Now, come. Here, 2 pair of peaks, no 2 pair of peaks. 2 pair of peaks, and we can select directly the house fly. Yeah, house fly is selected. House fly, okay. Then here, 2 pair of the house fly is selected. Also, butterfly. House fly. Butterfly and beetle there. What is the statement? Proboscis means what? Proboscis means? Ada multiple important kan mean? Ada wala butterfly ka imitate karan diwa. Proboscis means that one. The body part which used to get some honey. Proboscis. But beetle, does the beetle have proboscis? No, no. Beetle is not using the bee hunt, one of the bee, but flower honey. Multiple pollen. Yeah, now dead organic materials. They are eating normally dead organic materials. Right. And then the next statement is used there. That is number 3. Third one is used as the presence of proboscis. Proboscis present answer. Proboscis present in butterfly. Absent in beetle. Understood? This is the method of classifying the organisms using the dichotomous key. Okay? Key ekak kiyanne මෙහෙම එකක්. But so this is the scientific method of using a key. පොඩි කාලේ චූටි කාලේ දැන් ලොකු ඉන්නේ. හරි. චූටි කාලේ වල යූස් කරේ කොහොමද dichotomous key? මෙහෙම ගියා නේද? You say this is the dichotomous key you use. Yeah, to classify the things. But now we are using a separate dichotomous key. Okay. Then take out the separate sheet. Pota ganne pa. Pote antima pituwa hari naththam if you have a separate sheet, take out your hand. If you don't have extra paper, just take the last page of your paper. Yeah, that's it. How many of you didn't get last week? Last week means this one. That enaku kate ane pannatte hambune nathi එක. Kita sure? Ada ගෙදර තියන් දෙක දෙක. Sure? Right. Okay, are you ready? You take a separate paper? Yes. Okay. Now I will give you a list of organisms that is Start down this list. Parrot, fish, rabbit, housefly, and frog. Now, what is the best statements? Has wings. First one, write the first one there. Wings present, wings absent. Wings present, wings absent. Wings present, wings absent. Now, who are the ones with wings? Parrot and housefly. Then how many of them are there? Two. Without wings, fish, rabbit, and frog. We separate these two. First, how the parrot and housefly. Then I am using my second statement to classify these two. What is the one? Yes, presence of beak. Beak present. Beak absent. Then can I write the direct names? Can I? Yes, I can write the direct name. Beak present. Both parrot and beak absent. Housefly. Right. So they are now classified. Then I am selecting beings absent row. What is the number? Number 3. Remember, without selecting a single organism, I don't have right to write the list of organisms here. I can't write beings absent, fish, rabbit, mammalian, and rabbit. I have to classify it in another number. And this number system should be very continuous one. Beings absent, how many? Fish, rabbit, and frog. Have wet skin. Yes, wet skin. Yes. Wet skin. Third one. Wet skin. Wet skin. Absent. Wet skin present in frog, absent in fish and rabbit. Then I select the frog also. Yeah. Frog fish. Frog is selected. Wet skin absent in rabbit and fish. Now rabbit and fish should be classified in number 4. I am taking that then I am writing this. What? Not the skin, scales. Scales are there. And then number 4, rabbit and fish, fur. Fur and fur present in rabbit. Fur absent in fish. Right. This is one of the dichotomous key I can use to clarify the organism.
Sir, that's a free
Key. Okay. Now I write down my second list then. This one you have to do by yourself. Write down this list. You are given one. Now, in this particular system, we say differentiate them one by statement. They are not one statement. The opposite other statement is the opposite of the first statement. Like that. Now here they are like that. First, they may be a value. We have to take the relation and first we select the particular connector. What is the connector? Some of them have wings, some of them have two. Then you go to wings. Then I select that. Then I write it here. Some have wings, some have wings. Now, then I am going to classify them here. But here they are list butterfly, housefly, therefore I am writing the name of the organism here. So I am going to classify these three under character. Then I am selecting another character, these three, to classify them, to separate them again. Then butterfly, butterfly, housefly, I select here, butterfly, housefly, and bee. These three select. I observe them very carefully. I select some organisms have 4 pairs of wings. Some have 2 pairs. 2 pairs of wings and 4 wings. Some have 2 wings. Then from these 3, I select my second statement. Then 2 pairs of wings, absent of 2 pairs of wings. 2 pairs of wings are present in butterfly and beetle. Butterfly and the beetle for the children. Butterfly and the beetle. And then 2 pairs of wings are present in not in housefly. Therefore, I can represent housefly. But I have 2 organisms in this list. Then I will take that to classify as a Then I will take them to who are the butterfly and beetle. The butterfly beetle I will take care of this. What are the characteristics I can use to separate between the proboscis means that the get the female. Then one have proboscis, other one is this. I will take proboscis. Every time I select 2 times. Are you finished? Finished? Every time you are using 2 times statement there. Now, I will give you the exercise again. Just be careful. Not telling you again. Right? I have named, but that's good. Okay, now let's study. Right. And some of you, it seems that some of you may not get the idea clearly. Remember, when you are given this type of list, first, and you are going to classify them, you are going to identify them using a dichotomous list. Okay. First, what you should do here, select that first, observe carefully, observe the list of organisms very carefully, and then see what are the two statements I can use to classify them into two groups. Yes, some have wings, some don't have wings. So that is the statement I am using to classify them. First, my first statement is number one. I have to write. Number one, my first statement is wings present. Wings absent. And how many organisms with wings here? Crow and butterfly. I have two. Therefore, I am not writing the names of the organisms here. I am taking this crow and butterfly to my second statement. Wings absent, I keep it there. And first I solve these wings present cuts this figure. Then I will take these two, crow and butterfly, to my second one. So what is the statement I can use to separate these two? Has a beak, no beak, beak present, beak absent. Beak present, beak absent. Beak present, yes. Now I can write the beak. Present is crow, absent is butterfly. But here I have the other list. Initially I didn't classify. Wings absent, there are two, fish and rabbit. Then I have to take them into number 3. What is the one? Per present, per absent. The fourth one, per present. Yes, third one. Rabbit,